and technocrats and young budding engineers also. With this, keeping in mind these aims and objective of the Institution of Engineers has taken a good step to organize this webinar along with the technical seminars, workshops, conventions. Those who are not able to present for these physical seminars or workshop or lectures and take advantage of this knowledge, for them, this facility is opened up by the way of webinars by Institution of Engineers. And this today's lecture is also one amongst them. And this lecture is the Institution of Engineers has. This lecture is arranged with the initiative of Dr. Neelaj Kumar Deshmukh, who is the chairman of Mechanical Engineering Division Board, the Institution of Engineers. On this auspicious occasion, I welcome the eminent speaker of the today's lecture on the subject design thinking, Dr. Jyoti Sunil More, Associate Professor, Department of Computer Engineering, Father C. Rodrigues Institute of Technology, Vashi, Navi Mumbai. Welcome, madam.
Thank you, sir.
I also welcome the main brain behind in organizing this seminar, Dr. Neelaj Kumar Deshmukh, the chairman of Mechanical Engineering Division Board, the IEI, and he is a Dean Admin in Father C. Rodrigues College of Engineering, Vashi, Navi Mumbai. So welcome, Dr. Neelaj sir.
Thank you, sir. Thank you.
I also welcome the moderator of this session, Engineer Sunny Saraf, Assistant Professor, Department of Mechanical Engineering, Father C. Rodrigues Institute of Technology, Vashi, Navi Mumbai, and who is a convener in Civil Engineering Division Board in Navi Mumbai Local Center of the Institution of Engineers. So I welcome Sunny Saraf sir.
Thank you, sir.
And the person sitting at headquarters and who organizes, take care of all the activities and assembling all the reports and proposals of from various departments and makes all the arrangement, is a man behind in organizing these beautiful webinars. Is a Assistant Director, Dr. Kingshuk Sen. I welcome Kingshuk sir.
Thank you, sir.
And the most important, the participants in this seminar of design thinking, lot of interested professionals, technocrats, and students, young engineers also participating in this seminar on important subject, that is design thinking. So I welcome all the participants in this webinar and all. And now I request Kingshuk Sen sir to take over the charge and proceed further the proceedings of the today's webinar, sir. Over to Kingshuk sir.
Thank you, sir. Thank you, Engineer B.I. Chandrakant Kamble, sir, for your kind words. Sir, may I now request Dr. Neelaj Kumar Najukrao Deshmukh, sir, our Chairman, Mechanical Engineering Division Board of the Institution of Engineers India, to please brief the august audience regarding the theme. Sir.
Yeah. Thank you, Dr. Kingshuk. Respected dignitaries, esteemed colleagues, distinguished panelists, and participants, good morning to one and all. The Institute of Engineers India, with its century-long legacy of service to the nation, continue to foster innovation, knowledge sharing, and professional growth. Today's theme, design thinking, is not just a methodology, but a mindset that empower engineers and technologists to approach challenges with creativity, empathy, and practical problem solving. The program also marks a significant milestone under Mechanical Engineering Division Board, that is MCDB. We have successfully conducted 6 technical webinars in last 3 months. This consistency reflects our collective commitment to the professional development and relevance of IEA's mission in today's rapidly evolving engineering landscape. We are honored to have with us Dr. Jyoti More, Associate Professor at FCRIT Vashi, as our distinguished panelist. Her expertise and insight will enrich our understanding of how design thinking can transform engineering education and practice. I also acknowledge today's moderator, Engineer Sunny Saraf, whose guidance will ensure a smooth and engaging the sessions. I also would like to thank Engineer VC Kamble, Sir, Chairman Maharashtra State Center, and Dr. Pandarkar Sir, Honorary Secretary of Maharashtra State Center, who has taken the initiatives and submit the proposal to the MCDB for conducting this webinar. This webinar is approved as a continuing professional development, that is CPD program of IEA, and I encourage all the participants to actively engage, share perspectives, and take away the actionable ideas that can strengthen innovations in our institutions and industries. Let us together embrace the spirit of design thinking to innovate, to empathize, and create a solution that truly serve society. With this word, I declare the webinar open and invite our esteemed panelists to share their thoughts. Thank you.
Thank you, sir. A very good morning to all the esteemed participants.
Wait, Jyoti madam.
Yes, sir.
Madam,
Am I audible, sir?
Madam,
wait.
Madam,
Yes.
just I interrupt. Sorry to interruption.
Sure.
May I now request Sunny Saraf sir, our moderator of this session, to please introduce today's panelist, Dr. Jyoti More, and have a brief about this outcome. A brief outcome about the design thinking. Sir, Sunny Saraf sir, please.
Okay, thank you, sir. Okay, good morning, everyone. It is my privilege to introduce our speaker for the day, Dr. Jyoti More, whose expertise and contributions in her field have inspired many students and professionals. Dr. Jyoti Sudhil More is an accomplished academician and researcher with a PhD in computer engineering from University of Mumbai. She is working in Father C. Rodrigues Institute of Technology, Vashi, and currently serves as Associate Professor and Assistant Head of Computer Engineering Department. With 20 years of teaching experience, Dr. More specializes in machine learning, data science, business analytics, and social network analysis. Her expertise extends to research, wherein she has contributed as an author for more than 40 papers in reputed journals and conferences. She has also contributed as a peer reviewer for several reputed journals published by Elsevier, Springer, and Taylor and Francis,
Hello, I'm Amudar.
and also reviewed
Oh,
papers
okay.
for prestigious conferences. Beyond academia, Dr. More is actively engaged in guiding industry and research institute collaborated projects, fostering innovation and real-world application in cutting-edge technologies. Without taking much of your valuable time, I now invite you to begin this session. We eagerly look forward to your insights and learnings from your expertise. Over to you, ma'am.
Thank you, sir.
Just a minute, please. Actually, our honorary secretary, Sri Vasant Pandarkar sir, he has also joined. So I welcome him also. Good morning, Pandarkar sir.
Good morning, sir.
Good morning, sir.
Good morning to all. Yes. Yes, please continue.
Very good morning to all the esteemed participants. So before starting today's session, I would like to formally express my gratitude to all the dignitaries of IEI for giving me this opportunity. I would like to especially thank Dr. Nilesh Deshmukh sir, Dr. Pandarkar sir, Engineer Kamble sir, Dr. Sen sir, and Mr. Sunny Saraf sir for inviting me for this session. So I'll now formally start with the session. So can someone please acknowledge if the slide is visible?
Yes, ma'am. Visible. Please.
Yeah, thank you. Thank you very much, sir. So before starting the session, I would just ask everyone to ponder for a few seconds. Have you ever purchased a product that was technically excellent, but still found it frustrating to use? Maybe a complicated mobile app or a remote control like this with too many buttons. So there are operational issues, right? So even though the product is very useful, it is very tedious to remember all the functionalities. So as engineers, we often focus on making the things work, but we forget about very important thing, that is user experience. Now, let me give a brief case wherein this Apple Newton PDA failure was actually analyzed. So it is the early PDA introduced in 1993, and there were few design problems like handwriting recognition was inaccurate, and it was expensive and bulky also. So the lesson learned is even the innovative products like PDA can fail when the user experience is frustrating. Okay, so now I take you to another corner, that is educators. So many of us today's participants, they are educators, including me. So we focus on delivering the content correctly. But is that really enough? So just take few seconds and think over it. What if we say that real success of a solution depends not on what we build, but on how the people experience it? So this is exactly where the design thinking begins. So now, after laying the stage, we will now see how the design thinking can be dealt with. So I formally invite every one of you to think not like engineers, not like educators, but like designers. That is the people who first understand the humans, that is human needs, and then create the solutions around their needs. So today's agenda, to be brief, is finding the problem and the solution. So we will not focus on only the solution finding, but we will focus on finding the correct problem also. So this is the outline, formal outline of today's presentation. Firstly, we will see the context building. Then we'll see why the design matters. Then understanding the design thinking. Then we will see few real life case studies. Then the design thinking mindset, connecting to education, bridge to Industry 5.0 and NEP, and finally we'll conclude the session formally. So part one, so let me first make this confession that this particular session would not be only for industry or for academicians. This will be a blend of both industries. So that is why few examples, they will be related to industry and few will be academic specific. So part one is laying the context first. So that is from industry perspective. So this, we already know the paradigm shift. So if you observe the industry paradigms, the standards, they started long back in 1760, Industry 1.0, then formally defined as Industry 2.0 in 1870, then 3.0, 4.0, and now we are in the era of 5.0. So if you see this image, so I've mentioned the image courtesy also down. So if you see carefully, this image itself gives you a glimpse that this paradigm shift is not linear. It is exponential, right? So with the technologies that are developing at very fast pace, the industry paradigms are also shifting with a exponential growth. So the diagram, which specifies a staircase kind of uh, like a layout, will tell you about the exponentiation associated with it. So Industry 5.0, that is defined with three pillars: people centricity, resilience, and sustainability. So people centricity is nothing but human. Human is kept at the center stage, and all the innovations take place, that is, all the technical innovations takes place considering the human at the center. Then comes resilience. Resilience is nothing but the skill to adapt the changes very quickly and adapt the dynamics associated with it. And then the third pillar is very important, that is sustainable. So if any technology comes into picture, it has to stay there and it has to sustain with all the competitions or all the constraints associated with it. So in long run, any solution should be very much authentic. So these are the key Industry 5.0 skills. So I have listed all the skills that are required. So there may be many skills beyond this list also, but we are focusing on these skills: creativity, problem solving, design thinking, AI literacy, collaboration, sustainability mindset, emotional intelligence, innovation, critical thinking, and lifelong learning. So here we focus on our today's session, that is design thinking. Now let us see the education perspective. So we all know that in education, especially in the engineering era, we are in NEP 2020. So let us understand what are the expectations. So NEP 2020 has the following skills as a vision for the future engineering graduates. So these skills include experiential learning, multidisciplinary education, innovation and entrepreneurship, critical thinking, problem solving, skill-based learning, holistic development, research orientation, and ethics and values. So these are the necessary skills for any engineering graduate according to NEP 2020. Now, let us focus on our topic. So this is the prime objective, why the design matters. Now just take few seconds and see if there is anything wrong with this design. So if you see, there are stairs, but they are not leading to anywhere, right? So this is where there is nothing wrong with the design, but what about the utility? It is not leading to anywhere, right? Another example. So there is a fork and there is a spoon, nothing wrong with the designs, but just think of the utilities, right? So if the utility fails, that means you have a right product, but you are not using it rightly. Then also the user experience gets hampered like this. Design. Let us formally define the design. Design is an intentional process of translating human needs into functional solutions within the given constraints. Now just see why the design matters. So if you are given two options of these cars, so obviously I need not ask also which car would you like to drive or own, right? So this is the impact of the design. The more it appeals, the more you get attracted towards it. And obviously the other thing is user experience. So obviously, if the user experience in a particular car is more, then you are inclined towards that particular product. Then again, this is another importance of design, that is convenience. So if you see the design of this keyboard and the mouse, it is not conventional, right? So if the person is having special requirement and if he wants to spend more time, then to give extra convenience, this kind of design can be adopted. So this design is called ergonomic design, specially designed for the convenient usage. Now, let us understand the importance of design from few aspects. So first aspect is utility. That is, it solves the primary purpose. Let us take a simple example of a pen. So we know what is the primary purpose of pen and why it is designed like that. So we cannot just increase the width, the total circumference of the pen, which will hamper our experience of writing, right? Then next is peculiarity, that is uniqueness. For example, foldable smartphone. So our conventional smartphones are there, but foldable smartphones have its own uniqueness. The customers, a certain group of customers, they get attracted towards this kind of unique designs. Then next is distinguishing feature, that is against the competitors. So for any product to have its own strength in the market, they have to have some unique distinguishing feature. That is, for example, a washing machine. There are so many washing machines in the market. But if you add a distinguishing feature like it has a inbuilt heater or sometimes a inbuilt dryer, so that gives a distinguishing feature which makes the product stand out among the competitors. Then comes ergonomics, that is comfort of use. Just now we have visited that slide wherein I showed the comfort through special design of keyboard and mouse. Then safety, that is how do we minimize the risk through design. Like for example, an electric iron with auto shut off. Another very famous and daily usage example is our geysers with auto shut off functionality. So these obviously help us to increase the safety in the environment. The next feature is unique selling proposition. That is what we call as USP. That is the key benefit. Like for example, if I want to have a product to be sold in remote areas where they face the electricity issues, then I have to have a unique design wherein there could be a water purifier that works without electricity. So unless and until I have such kind of USP, I may not be able to stand or get my product to that kind of place, remote place, wherein they already struggle with the electricity issues. Then next is part of marketing strategy, like branding. Okay, so many marketing like taglines you might have heard, like for example, Tata, we say Desh ka namak. So it has nothing to do with patriotism, but still when we hear that line, Desh ka namak, we feel unknowingly that we are contributing something towards the country, right? So this is what is the emotional touch given to a particular brand. So eco-friendliness or CSR, these are the best examples. Now just take few seconds and observe this design. So this is the back cover of a classmate notebook. So everybody might have used this. Now carefully see here. I'm not sure whether it is visible. I'll read out. It says, classmate uses eco-friendly and elemental chlorine-free paper. So the moment you read this line, you will get a feel that you are contributing towards the environment. That means unknowingly, you are making something very good. And this emotion of yours is actually used for marketing, right? But now again, you see this. What is this trademark? It is ITC, right? A tobacco company, Indian Tobacco Company, right? So like without any offense, I would just like to emphasize that the right marketing will help the product to uh, gain the publicity. Then you may use the designs for improving sales also. So this is a classic example for this. So if you observe, there is just a small change. So what the change is? The opening of the toothpaste. It is just increased by 1 mm. Okay, so people unknowingly they squeeze out more toothpaste each time they use it, and the tubes emptied faster. And that was the reason why the sales went up without even investing on influencers or celebrities for advertise it. So this is how the sales also can be improved just by making a small change in the design. And now let us come back to the technical aspect. So these are the basic aspects of design: form, function, and human. So form is like how the product looks and feels, function is how it works, and then human is how the users experience it, understand it, and how they use it. So design thinking is somewhere in between human and the functions. Now let us go to our next session, that is understanding the design thinking. So formally, it is a problem solving approach which always keeps the user, that is human, at the center. It is always, often referred to as out of the box thinking. So when we say design thinking, it is not about the conventional design. So this is very important point to note. So this is a blend of out of box thinking as well as critical thinking. Now stereotypes. So the moment I see the first picture, I'll call that as Cadbury. But we know that it is not Cadbury, it is a chocolate, right? Cadbury is the name of company. But it is so famous that we unknowingly, even though we know that it is name of the company, we call that product as a Cadbury. Then second image is adhesive, but its brand is Fevicol. So when we go to buy it, we always say give a pack of Fevicol and not adhesive. Similarly, Xerox, very famous example. So we associate that unknowingly with a verb also. So we call that please give it for Xeroxing. So it is actually photocopying, and Xerox is the name of the company. But still, why this is happening is stereotyping. We have stereotyped all these products. So stereotyping is taking for granted. Or like one advantage of this kind of stereotyping is because we may have had a similar experience before. So these stereotypes will help us think very fast. So now let us take an academic example. So suppose there is a teacher and she is asking you all to draw a baby face. So what do you expect? So just this is the problem statement given. Draw a baby face on a paper. So most of you may end up drawing like this, right? So a cute human baby with a smile and three hair on the head. Because you have a stereotype. Whenever I say baby face, you will relate it to human baby only and a happy baby only because most of the babies are happy. So this is what is stereotyping. But what if I draw a baby face like this? Even this maps to the requirement, right? This is also a baby face. So this is where I think out of the box. So the left side of the picture is a stereotyped baby, and the right side of the picture is out of the box thought baby. Now, common practice is whenever there is a problem, people often jump quickly to generate the ideas and create the solution. They do not think the other way. They do not think out of the box way. So this is the common practice, and this is all because of stereotyping. Now, here comes the actual hero of today's session, that is design thinking. So in design thinking, first find the people who are facing the problem, interact with them, understand the actual problem, their actual needs by knowing them, what they are actually experiencing. And this is what is the main phase, that is empathy. So this is the engineering diagram. So there are 5 phases of design thinking. First phase is empathize, then define, ideate, prototype, and test. And the final phase after testing is the deployment, the actual usage of the product. Now, empathize is nothing but understanding the users as clearly as possible and empathize with them. In short, you are supposed to put yourself in somebody else's shoes who are actually needing that particular solution. So this is what is empathizing. Unless and until you empathize with the problem or with the person who is facing that problem, you will not be able to understand what are the needs and what solution you need to provide. Then second phase is define, that is clearly define the problem that needs to be sorted out and bring out multiple solutions. So these are all the feasible solutions. So after you understand the feasible solutions, then only you can find out the optimal one, the best one. Then the next phase is ideate, that is channel your focus on the final outcomes and not on the constraints only. So find out what could be the possible final outcomes. So for this, multiple approaches can be used like critical thinking, out of the box thinking, or any innovative solutions. Then next is prototyping. So whatever ideations you have in the previous stage, the third phase, for those particular ideations, you can have your own prototypes designed.
Madam,
So
sorry to
this,
disturb you.
yes, sir.
Your screen, you're sharing the slides where only that where I can see the bridge only, nothing else.
Sorry.
Slides are not visible.
Is it visible now?
Your screen, just bridge we can see.
Sir, it is visible to me.
No, sir, no, madam, screen is not coming.
I can able to see.
Just
Now, sir,
unshare
now
and
is it visible? Shall I reshare?
do one thing. Yeah, your network bandwidth is low, I think.
Okay, just 1 minute. Let me reshare once.
Yeah.
Maybe you can switch off your camera and then you can share.
Yeah.
Madam, please stop your share and you will share.
Sure, sure. Is it visible now, sir?
Yes, madam, it is coming.
Visible
Yes,
now?
Manoj. Yes.
Yes.
Thank you so much, sir, for letting me know this. Shall I proceed?
Yes. Yes.
Hello? Yeah. Okay, sir. So we were discussing about the prototyping. So once the ideation is ready with us, then we can go for different prototypings for exploring the possible solutions and then test the final stage, that is test your solutions. So it may happen that immediately after testing in the first go itself, you may not be able to get the right solution. So here comes the iterative phase. So you may go back, again empathize, again take the feedback from the user. Is this what they want? And then if you get a satisfactory feedback from the user, then you can go forward with the next stage, that is deployment, actual production of the design. Now we will discuss few real life case studies. So first case study is a scenario. So just see this very obvious kind of scenario in a traffic jam, and just see the ambulance that is stuck in the traffic jam, and imagine that you are in the car, one of these cars which are blocking the way of the ambulance. So it may happen that you are in the way and you start relating to that person's problems, right? So first thing is, once you come to know, the moment you come to know that you are blocking the way of an ambulance wherein some patient is getting carried, the first thought that comes to your mind is, what about the person inside the ambulance? So this is where you relate to that person, unknown person, unknowingly, right? So this is what is empathizing. You are putting yourself in that situation and then thinking about the environment. So suddenly you get the thought that I should do something, and then I should help the ambulance get the way for it. Okay. So this is the empathize and the define phase of design thinking. So in empathize phase, you start empathizing with the paramedics and the person in ambulance and try to figure out how to clear path, right? So ideate phase comes here after this. So in ideate phase, what you do is you try different approaches by moving left, right, or requesting someone to move and make the way for ambulance, right? So Ideate has different solutions and it builds the prototype. So once suppose you feel that this is the proper way, this is the optimized path by which you can let the ambulance move forward safely, you can then monitor the situation until the ambulance really moves forward. So this is the way it works on. Sometimes it happens that in one go, the ambulance may not find the way. So in that case, iteratively, you can ask the other cars to take the other paths and then find the solution. So this was the first classic case. Then second real life case was this water provision in West Bengal. So there was a government scheme. This is just a representational image. So there was a government scheme. So the case study is like this. In a remote village in West Bengal, people were having some issues related to health due to waterborne diseases. So there was lack of availability of clean water. So earlier provision was the water from well was transferred to the village and it was like 2 kilometers away from the village. So government launched a scheme for them. That is, they provided water tankers with a rate of reasonable rate of 20 rupees per 20 liter at a distance of only 0.5 kilometer, hardly 500 meters. But still, after doing this also, the scheme failed. So let us revisit this particular case study with design thinking. So what caused the system to fail? First is empathy. So by empathy, what we mean is let us understand the people's need. So for this, the user interview can be conducted. The information can be collected about the income, the family, the size of the family, I mean, then the kids, how many kids are there, and their ages also, because they may contribute in transferring the water also, and then they may contribute in the water usage also. Then type of the product expected and what are their real problems. So all these information has to be first collected. Then on the basis of this collected information, formally define the problem statement. And it may happen that they may face issues like bad roads, ladies had to carry water, maybe because gents are going on work. So ladies had to carry water. So lifting like 20-liter packaged water can in one go may not be feasible for the ladies. Then low income. So paying 20 rupees also they may not afford sometimes. Then there may be cases where the family size is very small and they need their requirement is less than 20 liter. So they may feel why to buy for this big water storage, right? So once we know what is the exact issue, then we can go forward with the next step, that is ideate, build prototype, and then test. So this was the another case study. So now let us discuss another case study, that is incubator in a cold area like Nepal. So in the hilly areas where the temperature is very low, often the infants they suffer with a medical condition called hypothermia, for which the infants are kept in the incubators. So this was the standard incubator which is used, and it is very costly affair actually. So Stanford, US Stanford, they proposed a solution. They first followed the empathy phase. That is, they collected the information from the doctors, nurses, the staff, and the local population. Then the formal problem was defined, and then the ideation phase was very interesting. First is because this particular case study was deployed in the hilly areas of Nepal, where the income was not that good, and also they suffered with the lack of electricity, also regular electricity. So they had to come with a solution wherein they had to give a free offering, then no need of electricity, and lightweight and portable also, because it is hilly area, so it should be very convenient for carrying the kids or infants. So it should be portable also. And the prototype they used was associated with few features like how it looks, how it will be used, what will be its cost, how safe it is, and what is the material requirement, because it is hypothermia. So some thermal material will be required, obviously. Then after that, testing. So this particular product developed by them was offered to the people for usage. Then they get the feedback from the people, and then as per the feedback, they iteratively refined their design. And the final product was something like this: very low cost product, durable, portable, hygienic, safe, and effective. And if you see the design, it is apt, it is portable also, and it looks inexpensive also as compared to the incubator which I showed previously. So this particular sleeping bag, it is called Embrace Sleeping Bag and developed by the Stanford. This is how the final product looked like. And there is another case wherein we will discuss Amul success story. So this is famous brand of India, the best dairy brand, what they claim. So in 1940s, so we'll just have a quick walkthrough through their journey, and we'll see how they succeeded. So in 1940s, the dairy farmers in Anand, they were exploited by the middlemen, and they received very low prices for the milk. So the Britisher Vergis Kurian, what he did is he first tried and empathized with all the stakeholders, not only with farmers, but the milk collectors, consumers, distributors. And before creating the solutions, he understood all the real pain points of all the stakeholders. So empathize phase is why the farmers are poor despite doing the milk business. What problems do the customers face? How can milk reach the cities fresh? These were the problems were like catered during the empathize phase. Then identifying the problem. So fair pricing, efficient collection, storage and distribution. These were the major problems that were dealt. The next phase is ideate phase, that is cooperative ownership, village collection centers, cold chain logistics, value-added dairy products. And the prototype built was, they started with local cooperative models, which still exists in the villages if we go and see. Then refined processes based on the feedback, and their expansion gradually across the India. So they had built their own transportation network across the India. This resulted in very famous white revolution, which increased farmer income, which led to affordable dairy products, and ultimately they claimed that it is world's largest dairy cooperative kind of mechanism, and this triggered India's white revolution, which was a very breakthrough, we can say, in the Indian white revolution. Then design thinking mindset, how it changes the user experience. Now, just imagine this user experience where there is a long queue in the restaurants and there is no place to sit, there is no convenience, and you have to take the stuff yourself, maybe. And imagine this kind of experience wherein your order will be displayed according to the tickets raised, and you need not wait there. So ultimately, when your order is displayed, you just get your ticket number and you go and collect it from the counter instead of waiting and wasting time there. So this was like McDonald's success story. So instead of waiting in a queue for giving the order and collecting, what they did was they built in a kiosk wherein you have flexibility to have your own choices, customize your order and place the order, even pay also. And then you can have your convenience. You can sit there conveniently and your order will be on your table. So this is the change of user experience. So the moment this experience was changed, the sales went up. Now, how the normal users see. So they see the flowers, they appreciate the beauty. Okay, beautiful flowers, beautiful color and all. Okay. Now, how the design thinkers observe and how they design. So the moment they see the same picture, they think from the design perspective. What is the symmetry? What is the texture? And what could be the softness, the um, other features of the flower? Okay, so observation is not what the eye see, but what the mind decodes. Now connecting this to education. So we have seen few industry or few societal case studies. Now let us connect this design thinking approach to education. Now, suppose there is a problem, a very famous problem, and we all experience it maybe sometimes. Students are not attending the lab sessions. So if we are following the critical thinking approach, which is a conventional approach, a typical engineering approach, we can say. So what we usually do, we analyze the attendance data, we identify the correlations, we evaluate the causes. Maybe the timings are early morning or maybe in afternoon when the students are not very interested or they may feel sleepy, clumsy like that. Then maybe difficulty of the subject may be the cause of less attendance. And sometimes some courses, they do not have that much weight. So that also may cause attending less. Then recommend the policy changes depending on these causes that are found. Okay, so this is the critical approach, critical thinking approach. Now let us revisit the same problem with design thinking approach. So here what we do is we'll follow our own strategy, that is first empathize, that is talk to the students, understand their problems. Next, observe their lab behavior. Next, understand the motivation, anxiety, and relevance. So, are the students feeling motivated to take up that lab? Do they feel that it is value addition to their curriculum or their skill set? Are they anxious about something from that lab? So, are they feeling that a particular topic is very complicated and that leads to anxiety? So sometimes because of that also students may skip the lab sessions. So once we understand these issues, then we can work upon redesigning the lab experience. Like we may adopt some additional teaching methodologies like peer learning, maybe flexible slots, giving real world context instead of following the conventional methodologies of taking the labs. Now, there is a hypothetical case study. So here I'm giving a disclaimer that any resemblance is purely a coincidence. So professor taught a technically strong course. So during this course delivery, the syllabus was complete, content was very accurate, and slides also were well prepared. Yet, result is the students kept failing. Now, if we deal this particular problem with our design thinking approach, so in one semester, let the professor ask the students, where do you actually get confused? How do you study? What scares you about this subject? So this is where the professor is actually trying to put himself or herself in the shoes of the students. They are thinking from students' perspective. So insight may be the students lack the prerequisite concepts because of which they are not able to understand these concepts, the current concepts. The examples felt disconnected from the reality. That may be the cause. Or there may be the cause of fear of asking questions which block the learning. Then the issue wasn't intelligence or right attitude. The issue was with learning experience design. So once this issue is found, then the professor can redefine the learning experience and solve the problem. So next part is bridging to the industry 5.0 and NAP. So how design thinking supports NAP 2020 goals? So in the start of the presentation, I had introduced the NAP goals. So after going through the design thinking slides, now let me map the design thinking contribution to the NAP goals. So this completes the cycle. So experiential learning, This can be catered using the real world problem solving through the design thinking. Critical thinking, it can be used for problem analysis. Creativity. So the ideation phase of design thinking can cater to this particular NAP goal. Innovation. So prototype development of design thinking phase can cater to this innovation goal of NAP. Entrepreneurship. So when we talk about the user-centric products, this will certainly help the entrepreneurship growth for NAP. Multidisciplinary learning. So when we are designing the product, we may need multiple team collaborations or solutions from multiple teams. So for this also, it will cater the multidisciplinary learning goal. And next, last one is holistic development, which can happen only through empathy and communication, which are the strong pillars of design thinking. Now, design thinking as Industry 5.0 enabler. So if you remember, Industry 5.0 has three pillars, major pillars: human centricity, sustainability, and innovation. So these three phases, empathize, define, and ideate, will cater to these pillars of Industry 5.0. Now, we all know that educators, they are more focusing on the sustainability design goals. SDG is what we call. So we can relate to most of those SDGs through design thinking. So I have listed few here. So I'll read out one SDG for you to understand how it can be catered. Like for example, SDG 3, that is good health and well-being. So in empathize phase, understanding the patients, doctors, and the caregiver challenges that could be analyzed. So for any problem which can be mapped for this SDG, this empathizing phase should cater all these requirements. Then define phase, that is identify the gaps in healthcare access, affordability, or quality. Then next phase is ideation phase, wherein generate the solutions such as telemedicine, health monitoring apps, or AI assisted diagnosis. So let me just give a disclaimer that these are just few samples. These are not the only samples, I can say. So depending on the problem statement, this ideation phase will be customized. Then prototyping, develop the pilot healthcare platforms or wellness programs. And test, that is evaluate the patient satisfaction, accessibility, and health outcomes. So this is just one example or one sample, you can say, wherein our design thinking can cater to the problem statements which map to this SDG. Similarly, these are few more examples, and you can explore more examples which can map to the SDG requirements using the design thinking. Now, the future engineer, that is Industry 5.0 ready engineer, he has to have these skills: technical skills, the human skills, and design thinking skills. So, with all these three, he can become a ready engineer, ready for this Industry 5.0 skills. So change in mindset. This helps in tackling the creative challenges. So if you see the object here, this is the real object. But if you see the object from this side, the left hand side, this is how the uh, perception will be. If you see the object from the right side, this is how the perception would be. So thinking of an object from different perspectives gives you different visions. So we cannot say that anybody's vision is right or wrong. This is the objective, but if the person is having this perspective, this is how the shape would appear to that person. And we cannot claim that this is the only perspective. There may be different perspective also. So obviously, when we talk about this design thinking, we should always keep in mind that there is an opportunity to look at the problems from completely different perspectives. So let us now conclude formally. So design thinking can act as a bridge between NEP 2020 and Industry 5.0. like what the educations are producing and how design thinking will be able to cater to the needs of 5.0 ready graduates. So ultimately, earlier we used to say that education and industry they are parallel, but parallel lines never meet. So now we have to redefine it and we have to say that education and industry they go hand in hand. Instead of saying parallel, we should use this term more aptly. So NEP 2020 has given the skill set like experiential learning, critical thinking, innovation, entrepreneurship, and all these will be clubbed together, integrated through design thinking to give creativity, human-centric solutions, collaboration, sustainability, and AI-human synergy. So in today's era, we cannot simply isolate AI from human synergy. So we have to think of this integration equally. And there comes the Industry 5.0 ready graduates. So with this, we can try and reduce the gap between education and industry. So takeaways, important takeaways are design thinking develops empathy-driven innovation. Industry 5.0 requires human-centric problem solvers. NEP 2020 empathizes experiential and multidisciplinary learning. Design thinking bridges Industry 5.0 skills with NEP goals. And the future professionals must combine technology, creativity, ethics, and sustainability, but all with human touch. So this is all about my today's session, and I'm open for questions. Thank you very much. Shall I stop sharing?
Yes, yes.
Yes, ma'am.
Thank you. Thank you very much.
Okay, anybody has any questions regarding this from the participants? I think so. There is no questions.
Okay, Mr. Sunny, you can conclude.
Okay, sir. Okay, before
Right.
vote of thanks, a short summary. That is, before we conclude, let me briefly summarize today's session. Dr. Jyoti More provided valuable insights into how design thinking helps transform problems into opportunities through a human-centered approach. Through thought-provoking examples such as the baby elephant story and the McDonald's customer-centric service model, we learned the importance of empathy, innovation, and challenging conventional assumptions. The sessions highlighted the difference between critical thinking and design thinking and demonstrated how both can be effectively applied in education and real-world problem solving. We also explored how design thinking supports the goal of NEP 2020 and contributes to achieving the sustainable development goals by encouraging creativity, innovation, collaboration, and sustainable solution. A key takeaway was that the future industry 5.0 engineer must possess not only strong technical skills but also human skills such as empathy, communication, adaptability, and leadership. Design thinking acts as the bridge that connects these competencies, enabling professionals to create solutions that are innovative, meaningful, and sustainable. Overall, today's session has inspired us to place people at the center of innovation and design solutions that create a positive impact on society. So we'll move forward for the vote of thanks. So as we come to the end of the insightful webinar, it is my privilege to propose the vote of thanks. First and foremost, I express my sincere gratitude to our esteemed speaker, Dr. Jyoti Sunil More, for delivering a highly informative and engaging sessions on design thinking. Your valuable insights on innovation, empathy, creativity, and problem solving have enriched our understanding that inspired us to think differently while addressing real world challenges. I would also like to extend my heartfelt thanks to Engineer Vijay Chandrakant Kamble, Chairman IEI Maharashtra State Center, Dr. Kingsuk Sen, AD IEI, Engineer Vasant Dattarai Pandarkar, Honorary Secretary III Maharashtra State Center, Dr. Nilesh Kumar Najuk Rao Deshmukh, Chairman, Mechanical Engineering Division Board III, for their constant support, encouragement, and guidance in making the webinar possible. My sincere appreciations goes to the Institution of Engineers India, Maharashtra State Center, the Mechanical Engineering Division, and Father C. Rodrigues Institute of Technology, Vashi, for successfully organizing this technical webinar. I would also like to thank all the participants who joined us through Zoom, actively interacted during this session. A special word of appreciation goes to the viewers who joined us through YouTube Live and contributed to the success of the event through their enthusiastic participation. Once again, thank you to our speaker, distinguished dignitaries, organizers, participants, and viewers for making today's webinar a memorable and successful learning experience. Thank you and have a wonderful day ahead. With this, we conclude today's webinar. Thank you once again for participation and support. Stay safe, stay curious, and keep learning. Have a great day ahead.
Thank you all. We'll conclude.
Okay, thank you, sir.
Thank you all. Really, Jyoti madam, very nice session.
Thank you very much, sir.
And I forgotten to actually take the name of Father C. Rodrigues College of Engineering at the beginning only. So thank you all the management and officials of Father C. Rodrigues College of Engineering for holding this seminar in association with Institution of Engineers. So thank you.
Thank you, sir. Thank you,
Thank
sir.
you, sir.
Thank you for your kind words. Thank you. Yes, Sunny, you can end the meeting.
Okay, sir. Thank you.
रेकॉर्डिंग स्टॉप झालं तर आता बोलू शकतो. म्हणजे